We're going to combine chapters 13 and 14 together and look at them together. And in this section, we're going to see that inferential statistics starts coming together and it becomes practical as we look at our what's going to be known as t-tests. T-tests are a broad group of tests that we're going to be able to use to see if we can be sure that two samples that are different in some variable indicate if that means that they come from different populations, if the two samples are really different types of people or places or wherever they're coming from. We're going to be able to tell if there's a difference between two groups using a t-test. We're also going to be using t-tests to look at correlations to see if we can be sure that a correlation really exists in a population or if it might be spurious. So this is an extremely important section because we're going to be using significant tests, which we've been studying in the previous sections, and apply it to two really practical questions. Are these two groups different? And are these two variables really related? Now let's have a little review quiz to make sure that some of the material from the last section stuck together. So it says that you measure the stress level of 7 employees in a division undergoing major restructuring to see if their stress level is different than the stress level of the average employee. So you've got the stress level of the average employee. Their average stress level, the 7 people's, was 7.6, higher than the 5.5 average for the average employee. So we've got a sample mean of 7.6, so they're more stressed out than the population average 5.5. We want to find out if that's statistically significant to see if that, oh, wow, in this division that's being restructured, people are more stressed. Or, oh, well, this is kind of what we could expect if we just had a sample of 7 people and they weren't more stressed. So your null hypothesis is that the stress of division members equals the stress of the average employee. There's no difference. You do a z-test and you get a z of 4. Now, your z-critical is 1.96. We did a two-tailed test. Do we reject the null hypothesis? That's the question. Can we reject the null hypothesis that there's no difference in stress, that there really is a difference in stress level? Well, we know that we got a z of 4 and our z critical is 1.96. That means we've got a really big z score, which means it didn't happen by chance. They really are more stressed out. So we can reject the null hypothesis and come to the conclusion that, yeah, they are. There is a difference in stress level. These employees are stressed out more. So this is an example of how we do inferential testing. We calculate a statistic. Here we got our z statistic of 4, and we see how big it is. And we can see how big it is either by comparing it to a critical value or looking at the probability associated with it. The bigger the statistic, so for example, z, the lower the probability of getting that by chance is, and we reject the null hypothesis. So high statistic means low probability, means reject the null hypothesis, means that our main hypothesis is likely to be true.